Okay, so now that you know a little bit more about scope and the lifetime of variables, I'd like to talk about static data. Just to review here, when you have a local variable that is created inside of a function, we talked about the scope. It can only be seen and used inside of this function, but also the lifetime of that variable. This variable only exists in memory while this function is running. And when this function is done running, some var will fall out of memory, as we say, and it no longer exists, and that memory is returned to the system. So with that in mind, let's just look at a quick demo. I have the sum func, okay? It's a very basic function. We're creating a variable called sum var. We're going to add 10 to the value of sum var. We're going to increment that by 10 or increase by 10. And then we'll just print the value of sum var. I am keeping track of the demo count. I'm doing this as a parameter. So we're going to, every time we call this function, we're going to pass the count. Well, I have a loop counter down below, and we'll just pass it. So it'll say value of sum var after demo count 1 is whatever, demo count 2, demo count 3. So it's just going to be like a 1 through 10 type of thing. So that's really the role of demo count in here. It's not really important to the discussion, so to speak. So anyway, down here in main, I'm calling sum func. Notice my loop counter I, I'm starting at 1, I'm ending at 10. So as this loop is running, the value of I is going to be 1, 2, 3, 4, 5, and so on through 10. And every iteration of the loop, I'm calling sum func up above, and I am passing the value of that loop counter into demo count. So let's run the program and see what we get. Really, the focus here is on sum var and the value of sum var, because after every time I'm calling this function, I'm calling this function 10 times in this program. Every time I'm incrementing the value of sum var by 10. So let's run this. Okay, so look at this. Every time it's 10. And the point here is this variable has local scope, and more importantly, the lifetime of this variable is short. Okay, it only exists in memory while this function is running, and as soon as we get to here, it is gone. It disappears. Sum var disappears. It no longer exists. And so it's wiped out of memory, as well as any value that it had in it, inside of it. So every time we're calling this function, it's like we're recreating a brand new sum var. We're initializing it to 0. We're incrementing it by 10. And so we get 10 every time, because it never retains its value, because its lifetime is so short, and once the function is over, it's over. It doesn't exist anymore. So every time we call this function, we're creating a brand new sum var. We're starting all over again with the initial value. So let's look at another way of doing it. Okay, there's a keyword called static. Okay, so I'm going to put static, the static qualifier. All right, and now I'm going to run this program again. Let's look at the result. Okay, so this changes things. You can see every time I increment by 10, it's holding its value. So what does this mean? The static qualifier, when you make a variable static, the scope is still local. This sum var can still only be seen from within this function, but the lifetime is different. With the word static, that variable will persist in memory. It persists in memory, and it retains its value even when the function is done running. It's still going to hold in memory, and it will hang on to its value. So, I like to think of it as like, you think of static clean, makes things sticky, things stick to your pants. Static makes a variable stick in memory. Sticks in memory and holds its value. So that's one way of remembering that.